Hello everyone, my name is Deepak Kumar Patel. Today I am going to show you my exploratory data analysis on hard disease dataset. So I am having this dataset which consists the data of all the patients who are submitted as having a heart disease. This dataset consists of chest pain type, resting BP, cholesterol, etc. of the people who were admitted in the hospital for having a heart disease. And at the end, it also has a column which shows that whether they were actually having heart disease or not. So the objective of this data set was to find out a relation between all of these columns for it having or not having a heart disease. So the first step of the idea was to import the libraries used in it. The libraries used by me were Pandas, Matplotlib and Seaborn. The second step was to import the data of the data set. So I have used Pandas or read CSV to import the data from hard.csv into this notebook. And if you look at the shape of this data set, you will find out that it has 12 columns and 918 rows. And if you look at .info of this data set, you will find out that it didn't have any null value. So if this data set had any null value, you would have to fill it using any such method. Now, but since the data set doesn't have any null value, we can move ahead. Data frame.describe shows you some basic information about this data set. For example, the mean age was 53, the minimum age was 28, which means there was a patient who was the minimum age of the people who was admitted as heart disease patient was 28, and the average resting BP was 132, average cholesterol was around 198, etc. Now moving ahead, if we find out some basic counts of the data set, you will find out that 725 were male and 193 were female. 496 people were having ASY type of chest pain type, and 460 were having ST slope, flat ST slope. Now this value count doesn't tell us that whether these people were having a heart disease or not. So to differentiate it correctly, I have divided the data frame into two parts. The first part is that the people having a heart disease, and the second part of people not having heart disease. So as you can see in this data set, in the heart disease column, if the column has 1 in it, which this means the patient was having a heart disease, and if it has 0, which means the patient does not have a heart disease. So to make it more readable, I have replaced 1 with yes and 0 with no, and then divided into two different data frames. So now you can see that out of the people having heart diseases, 458 were men and 50 were female, and out of the people who were not having heart disease, 267 was male and 143 were female, and out of the people having heart disease, 392 were having ASY type of chest pain type. So now you can easily differentiate the data of the people having and not having heart disease. Now instead of reading such data, it's better to visualize it. So I have used many plots and graphs to make it more appealing. As you can see in this, the people having heart disease were around 500 and not having heart disease were around 400 out of the people in this data set. And if we compare it gender wise, 90.2% were male and 9.8% were female. And as you can see a clearly spike of ASY chest pain type for the patients who are having heart disease. Now I have used many such graphs and plots to make this data more visually appealing. At the end, I have written some of the key insights found by me. For example, the average resting BP in heart patients for 132, average cholesterol in heart patients for 198. Patients are more likely to face a heart disease if their SR slope is flat and least likely to face it if it is up, etc. So this was it from my side. Thank you and have a nice day ahead.